Welcome to our presentation on Jeka. Today, we'll demonstrate how Jeka simplifies building Spring Boot applications and converting them into Docker images, whether native or JVM-based. First, we'll show how to create optimized JVM-based or native images without any configuration. Then, we'll explore ways to customize them. And finally, we'll demonstrate how to implement pipelines for deployment. For starting, let's create a new Spring Boot project. Jeka generates a pre-configured, fully functional Hello World project. This scaffold project includes a basic structure, a minimal application class, and an integration test to ensure everything works out of the box. The scaffold Jeka.properties file mentioned the latest Jeka and Java LTS version. We also use the Spring Boot plugin fetch from Maven Central. Project dependencies are specified in a dedicated file, separate from the general configuration, to enhance clarity and maintainability. We can compile, launch test, and create the bootable jar using the pack method from Project Kbean. The bootable jar is generated in Jeka output directory. The built jar can be executed using the runjar method. We can verify in a browser that the application is running successfully. Now, we'll build a Docker image of the application just by invoking the build method from the Docker Kbean. The image is built using the Docker CLI and is stored by default in the local registry. The console output includes the command to run the image with the correct port mapping. Again, we can quickly check in the browser that the application is running properly before exploring the details of the image composition. The Docker info method in Jeka displays details like the Docker file and the contents of each Java layer. Additionally, you can navigate through the generated build context directory used for creating the image. This is particularly useful for inspecting intermediate results and replaying the build process for debugging. All right, let's create a Docker native image, an image containing the application compiled to native code. To achieve this, simply run the build native method from the Docker Kbean. The native image produces a more compact Docker image that consumes fewer resources and starts up significantly faster. These characteristics are especially valuable in typical cloud scenarios, helping to reduce costs and enabling new instances to spin up instantly as load increases. Jeka uses a lightweight approach where only the native compilation runs in a container, while the rest of the build stays on the host, enabling easier troubleshooting and efficiency. Only 50 seconds are needed to create the native image on the demo laptop. Well, now let's run the native image. We can notice that the application starts almost instantly, in less than 30 milliseconds. Let's do a quick check to ensure the application runs normally. Okay, now let's inspect the composition of the native image. We can either run the Jeka Docker info native method or explore the build context directory. The native image is a multi-stage build, where the native executable is created first and then copied into the production image. By default, the image includes a non-root user for enhanced security. Great! Now let's look at how to customize the generated image. First, we'll switch the native base image to an optimized one that reduces size and attack surface. By comparing the image sizes, we can see that the native image is half the size of the JVM one. We'll edit the Jeka.properties file to configure a distroless image. This requires statically linking the native executable to a libc library, as it is not included in such distributions. Now, let's proceed to rebuild the Docker image, this time using the updated configuration with the optimized setup. We can see that the image size has been reduced by half, weighing around 80 megabytes. Now we'll go deeper in configuration using the Java API that allow to customize the Docker file programmatically. First, we grab a reference on the Docker Kbean singleton. Then we add configuration code in the init method, which is called once by Jeka in the startup process. The Docker Kbean offers methods to customize the generated Docker build directory through an instance of the Docker JVM build class. This class allows you to modify the Docker file and dynamically import files into the build context directory. For instance, we add the OpenTelemetry agent by specifying its Maven coordinates and configure it using environment variables. This change is reflected when executing the info method. We can see that the Docker file now includes environment variable declarations, and the Java command has an option for the OpenTelemetry agent. Now, let's proceed to rebuild the image with the updated configuration and run it to verify the changes. By checking the logs, we can confirm that OpenTelemetry is now active and properly integrated. In the final chapter, we'll explore an example of how Jeka can delegate image builds to facilitate pipeline delivery. Let's imagine you want to test your image locally before publishing it to Docker Hub. We can create a publish image method that runs the image locally, executes tests on it, and publishes it to Docker Hub if everything passes successfully. Let's run this method from the command line. Next, run the published image. We can verify that it is effectively accessible. We've reached the end. You now know how to use Jeka to efficiently create Docker images for your projects with minimal effort. Take note of the concise configuration required compared to other tools. You've also seen how properties and Java combine to deliver both simplicity and power. This concludes our walkthrough of native cloud with SpringBoot and Jeka. Please don't hesitate to share your experience and feedback on using Jeka in the GitHub discussion page. You'll find resource links in the video description. Have fun, and thank you for watching.